Hi there, welcome to this short video on parallel circuit calculations. So here's the basics. We have two 1 ohm resistors connected in parallel with each other. We have some options when it comes to calculating its expected resistance. Option number 1, if they're the same value of resistance, you take the resistance of one of the branches and you divide it by the total number of the branches that are present. Okay, so you'll see there we have two 1 ohm resistors in parallel with each other. So I take one of those resistances, 1 ohm, and divide it by the total number of branches. So you'll see there we have two branches. So 1 divided by 2 gives us an accumulated resistance in this parallel circuit of 0.5 of an ohm. Okay, so let's look at it slightly more advanced. Parallel circuit, I have four 1 ohm resistors all in parallel with each other. So simple form, we take one of the resistances because they are all the same and we divide it by the total number of branches. So 1 ohm divided by 4 gives us a parallel resistance of this entire circuit here of 0.25 of an ohm. What other way could we carry this out? Well, we could carry it out using a product sum calculation, but this only works on two branches at a time. Okay, so it's if we have two resistances in parallel, straightforward enough, carry out a product sum. What's a product sum? Well, a product sum is where we take the product of the two resistances, so we multiply the two resistances together and divide it by the sum of the resistances, so we add them together. So 1 times 1 is 1, 1 plus 1 is 2, divide the product by the sum, gives us that same 0.5 of an ohm of resistance. Okay. Again, slightly more complex, where we have four parallel branches. We take two at a time, so we're going to take this blue pair and then we're going to take this red pair at a time. So product sum, we take the blue pair, 1 ohm and 1 ohm, 1 times 1, times this divided by the sum, which is 1 plus 1. So we have that same 1 over 2. Gives us 0.5 of an ohm for the accumulated resistance of this side. And then we do the same for the red side, where we have 1 ohm plus 1 ohm in the sum and 1 times 1 on the product at the top. So that gives us 0.5 ohms for the accumulated blue side and the accumulated red side. So that circuit then now looks like this, where we have 0.5 of an ohm accumulated on the blue and 0.5 of an ohm accumulated on the red side. Okay, and we do the exact same process again, where we do the product sum again. So we take 0.5 times 0.5, that gives us 0.25, and then we take the sum, 0.5 plus 0.5, that then gives us the 1 ohm at the bottom. So we take 0.25 and divide it by 1 and we get 0.25 of an ohm. Okay. Option number 3, well, we can carry out a 1 over RT calculation. This is probably one that you are more familiar with. Okay. So what's a 1 over RT calculation? Well, 1 over RT is where we take 1 over R1 plus 1 over R2 plus 1 over R3 plus 1 over however many parallel branches that there are. Okay, so in this instance here, it's possibly best to think of this calculation like this wee triangle, where we have that 1 over on the RT at the side, and then we have the sum of these 1 over R1 through to 1 over Rx or Rn, whatever it is that we have here in your note. Okay, so 1 over RT equals 1 over R1 plus 1 over R2. So 1 over 1 plus 1 over 1 gives us 2, because 1 over 1 gives us 1, 1 over 1 gives us 1 here as well, so 1 plus 1 is 2, okay? We then transpose the formula, so you can divide out either side or multiply out whatever way it is that you want to work it out, or as I tell the apprentices, just move the hat, move the 1 over here and just bring it over to this side, okay? So we get 1 over 2 gives us 0.5 of an ohm. Okay. Slightly more complex, we have 4 branches, but again all 1 ohm. So 1 over 1 plus 1 over 1 plus 1 over 1 plus 1 over 1 for the blue, red, green and black resistances that are up here. Okay, so the accumulated resistance or the accumulated sum we have here is 4, but remember it's not the actual resistance because we've actually just found 1 over RT. So again, we take that 1 and we pop it across to the other side to find RT. So RT equals 1 over 4, which gives us a total resistance for this parallel circuit of 0.25 of an ohm. So let's look at it as a slightly more complex parallel circuit. Okay, I'll have a 10 ohm, a 50 ohm, a 6 ohm and a 30 ohm resistance in parallel with each other. And we follow through the same process where we take 1 over 10 plus 1 over 50 plus 1 over 6 plus 1 over 30 for each of these resistances and we add them together. So first off, 1 over 10 gives us 0.1, 1 over 50 gives us 0.02, 1 over 6 gives us 0.16666666666 forever into infinity. So we've rounded that to 0.1667 and then 1 over 30 gives us 0.03333, again off into infinity. So when you do this on your calculator, you should get 0.32 as your answer. All right. We take that 0.32 and remember we're looking to bring, it's 1 over RT is what we've found. So we need to bring this 1 down to find our RT. Okay. So RT equals 1 divided by 0.32, which gives us an accumulated resistance of 3.125 ohms for this entire parallel circuit. Okay. Another way in which we can carry this out, well, as I said, most of us are familiar with this 1 over RT calculation, but you might not be aware of it. But on your calculator, you have an x to the minus 1 button, or it might on your calculator have a 1 over x button. Either way, they do the exact same thing. Okay, what they do is they take the figure that you punch in, and when you press this button here, they turn it into this fraction. Okay, so trying its basic function, if I punch in 2 and then hit my x to the minus 1 or my 1 over x, it then gives us, and hit the answer button or hit the equals button, it then gives us 0.5 as my final answer for that. So it makes it that fraction, it puts it in as the denominator. Yeah, so it puts that 1 over as the numerator over the top of the number that we've just punched in. Okay. So option number 1 for using this x to the minus 1 button, we can use those figures from the last calculation where we have 10, hit the x to the minus 1 button, plus 50, x to the minus 1, plus 6, x to the minus 1, plus 30, x to the minus 1 would give us that same 0.3